Welcome to qnawire.
We're given a disk attached to an arm ABC, and we're asked to find its angular momentum about the point C. So I found the directions of the different angular velocities by using the right-hand rule. So we have omega 1 here and omega 2 here. And also notice that there's no angular velocity in the x direction. So that also means that there's going to be no angular momentum in the x direction either. So to start solving this problem, we're going to write the different components of the angular velocity in the different directions. So I've already said that the angular velocity in the x direction is equal to 0, and the angular velocity in the y direction, that's going to be equal to this omega 1 here, which is equal to 5 radians per second. So this is omega 1, and it's given as 5 radians per second. And omega z, that's going to be equal to this angular velocity, and it's given as 15 radians per second. So now we write the equations for the moment of inertia across the different directions. So the moment of inertia in the x direction, we know it is 1 over 4 times the mass of the disk times the radius of the disk squared. So we can plug in the mass and we can plug in the radius. So the mass is given as 4 kilograms, and the radius is given as 0.150 meters squared. So we'll get a moment of inertia about the point x of 0.0225 kilograms meters squared. And for the y direction, we also use the same formula. So we plug in the same values, and we'll get the same answer for the x direction. Now for the z component, moment of inertia in the z direction, this is going to be equal to 1 over 2 times the mass times the radius squared. And we plug in the mass, and we plug in the radius, and this will give us a value of 0.045 kilogram meters squared. So we can now write the formula for the angular momentum about the point C on the disk. So this is equal to I of x times omega xi plus I of y times omega y j plus I of z times omega z k. So now we just plug in the known values. So Ix we know is 0.0225, and omega x is 0. I of y is 0.0225, and omega y is 5. And I of z we calculated to be 0.045, and omega z is 15. So we simplify this answer, and we'll get a final answer of 0.1125 J plus 0.675 K kilogram meters squared per second. And this is our angular momentum.